Perfect. So thanks everybody for coming. So this is the second meeting of May of the performance team group, not performance team group, performance team. Before we start, are there any announcements that you would like to share? I can share some small stuff. I started working on a very old issue created by Robert regarding buffer byte length. And I'm working on adding SIMD instructions. It's going to be a bumpy road because I need to write more than 4 different versions of the same function. But right now, we have found around 2.5 times faster solution for 1 byte length UTF-8 byte length calculation, which is really good. So
relative to auto vectorization?
Yes. So
cool.
auto vectorization is not performant enough. So using specific SIMD is always faster. And there was this new contributor, actually a Node collaborator, who suggested 2 times faster solution than mine. So it was really good. I am learning new stuff and it's pretty exciting. Yeah. Are there any other announcements that you would like to share? Perfect. So we have a really quite small agenda for today. The first issue on the agenda is improve legacy CGS resolve. Issue number 73. This is created by me. The issue is that for certain packages in CGS, if main is not equal to undefined, then we check for every different existence of files. This is particularly slow for 2 main reasons. One of them is every new URL instantiation means that there is a 1 C++ boundary. And after that, we also call file exist method, which is also one more iteration of communicating with the C++ code. So this runs around 6 times in the else if loop. So 12 different C++ iterations have been done. If we just reduce it into 1, then we would have a significantly more than 2 times faster execution for this particular code. Ado recommended that this is particularly not highly to be used, but again, this code lives in Node.js core, and I think that this requires the attendance and the attention of the performance team, because there will be packages that will use this. Any questions? Anybody want any idea? It's pretty straightforward. If you have written C++ code, or if you want to contribute to C++ code, this would be a really great idea, because you will interact with Ada, you will interact with libuv files for file system existence check. So yeah, I will be happy to help anybody who is interested.
So basically, we would have to move this and all these file checks into the C++ side instead of this side.
Yes, that's correct. Okay. So a single function that takes a string parameter and returns a string parameter is sufficient, I guess.
I see. Okay.
So yeah, the good side is there are lots of optimization like these in Node.js core. For the rest of the year, I'm planning on top of of course, on top of significant changes, I am planning on reducing these C++ calls as much as possible, because they're easy to fix and also has a high impact. So yeah, this would be a really good task to do, I guess. So we can, I recommend keeping this in the performance agenda in case anybody wants to contribute or have any questions. And it would be a good issue to introduce more collaborators into the Node.js performance team, because yeah, the solution, the problem that it solves exists in most places. So yeah. The second, if there isn't any other comments or feedback, then we can continue to the second agenda item. So the second agenda item is issue number 24, which is make callback is very slow. Robert created it. Robert, if you like to explain it in a few words.
Yeah, so right now calling from JavaScript to V8 or native is pretty fast, especially with the fast call. But going the other direction from native to JavaScript is very slow, relatively speaking. I know micro WebSockets have been fighting that fight for a long time, but how slow it is to call from native to JavaScript. I believe a lot of the overhead is due to all of the async hooks code. I don't know how to make it faster. It's quite tricky with all the async hook stuff.
Can you explain where make callback is executed? Like, can you give an example?
So if I have a WebSocket server, and items are arriving quickly, and then you call back into JavaScript that, oh, here is more buffers for you, please take them, and there is quite a heavy overhead.
So in the C++ code, you are triggering a JavaScript object or a function, and you are mutating it. Is that the correct assumption there?
No, make callback is that you basically call back into JavaScript. So you can have a function that calls an async native function, right?
Okay.
And you want to call back with the result into JavaScript. That's also a common case. And that back call is very slow relative to the other direction.
I've faced a similar performance regression while I was working with URL parser, because previous URL parser was using a callback which mutated the arguments of the callback function, and because it included strings and blah blah. So I tried to fix it by reducing string operations, but the issues still exist. So I added this to the performance agenda because I think this is a really high impact issue that we should focus on, and I think we are on the same page with you on this.
Yeah.
If you could if we could get some help from people who are more experienced in this, I would like to look into it and understand, or at least share my thought process and experience that I gained, so that future generations of collaborators can leverage from it. That would be, I think, super helpful.
There is also one path which I'm not convinced of the usefulness of, is to provide a compiler flag when building Node to entirely disable async hooks for those that don't need it. Because most of the overhead in make callback comes from the async hooks, and stuff that needs to happen.
So in that particular scenario, should we, like, the goal of having a build flag is to distribute Node.js without async hooks, and would it be applicable in the real world scenario, or in the future, is there a possibility that Node.js would distribute it?
No, I don't think so. It's a very niche for those users that are very performance sensitive, and they would have to build it themselves. A little bit like with pointer compressions today.
Can we introduce a runtime flag that does a similar thing but with less overhead?
Possibly. That's
okay.
Also a possibility. With branch prediction today, just having a if-else should be sufficient. I don't know how complicated the whole async hook make callback stuff is. I haven't dug into it much myself either.
Do you know who is more like has more knowledge on this?
I think it's Anna that has done most work on that.
Okay.
I think Joey maybe would also be. I think Anna has done some. I have brought this up in the past also, and she did some optimizations there. But I think if someone would actually sit down with it more, sit down and look it through, there are probably opportunities to optimize that even further.
Okay. Yeah.
And I actually don't know that we have problems with async hooks in general because they don't work with they don't work well with ESM modules.
Yeah.
So in that perspective, if we're going to the ESM way of things, I don't know how that affects async hooks and their relevance. I think I would need Matteo for that conversation.
Yeah. Would you be interested in sharing this in the TFC meeting and asking for any help?
Yeah, sure.
I think most of the people that you mentioned are in TSC, and I can also do that because I'm the performance initiative champion. So
yeah,
would that be helpful? I don't know how to reach all of those people at once instead of going one by one. So
yeah, I mean, one way is to ping them in the issue tracker, in the performance issue tracker. I could do that. I think that's the first step because, or just yeah. But we could also, if we have a little mini report from the performance team, to just shortly mention it for visibility.
Yes, perfect. I think Ulysses is right now updating the documentation, so thank you for that. So I recommend keeping this in the agenda, and even though we don't have any actionable items right now, I think gathering information is also really important for this particular task. So the next item on the agenda is fetch issue 11. Yes, Robert opened this issue, so can I toss the ball to you? There's the performance of fetch is not as expected as it should be. There's no new updates as far as I can see. Is there any?
I'm also, I'm on the performance team, so I shouldn't be saying this, but how much time do we want to spend optimizing fetch? What's our status relative to like Dino in terms of performance at the moment?
So in terms of fetch, so fetch works on the readable stream, what.yg stream, I think, right? So I had submitted a PR into Yagis's this benchmarks repository. So our readable stream.read is approximately 30-40% slower than Pun and Dino, right? Maybe so. If we can speed that up, then everything else is more or less same. Just that one part needs to be looked into. So that could be one area to look at. How to speed up a readable stream.read.
Yeah, I think right now the readable stream stuff is the next thing to optimize.
Yes, I think we should open an issue on performance. Badre, can you open an issue with the result of your benchmarks that you opened?
Sure.
I would appreciate it. And thank you for the pull request. I shared the URL in the Zoom chat. What I really like is that these kinds of small benchmarks show where we are lacking some certain optimizations compared to other alternatives. and it's extremely valuable. So again, thank you for that. So I think that's it for today's meeting. Are there any questions that you would like to share? Share?
Wait, I was thinking of something. What was that? Now I
There's
missed.
one particular issue that Vinicius opened, which was is trace HTTP enable.
Yes, thank you. What is that
Yeah.
issue? I was looking for that.
Let me share the link with you. Number 81.
Is that in our performance repo? That's why I couldn't find
Yes, yes.
it.
So what I want to ask is, so we can always add optimizations to access this. It seems that Fast API is not possible because this HTTP trace enabled comes from V8 itself. We could add an optimization, just like Matteo said, by patching the enable function and storing the pointer and accessing it on the JavaScript side. But my question is, why do we need to call this function in every HTTP request? Why don't we cache it? Can this flag be changed on the runtime?
Yes, and it can be changed by native code. So you could have a plugin, an add-on, a Node add-on that calls into V8 to change the flag.
So in that scenario, we can just have a big cache object and store those kinds of information in the JavaScript side. Whenever C++ code changes those tracing flags, just store them on the JavaScript side and access them through JavaScript.
But what about Ben's suggestion? That seems rather straightforward. To just expose
accessing
an array buffer.
Yes, but every access to that array buffer is going to be changed as well.
What do you mean?
What is the cost of accessing that shared array buffer between JavaScript and C++? It's costly than creating and accessing a JavaScript object, right? Or is it same?
It's the same. It's basically as accessing an array. So
okay.
I would say the cost is negligible.
Okay. So then I think my solution is the same as Ben's.
Yeah.
I was just thinking about putting all of those flags into one place instead of solving this particular problem, because I think the problem of accessing these flags exists in anywhere in Node, but because they mostly call it one time, or maybe we didn't have any other person, just like Vinicius benchmarked it, we didn't realize it.
I mean, other options are also is to just poll these flags once a second. I don't know how recent they need to be, but
yeah.
I think this specific case, Ben's solution is probably the best one.
Yeah, that would be perfect. Vinicius, do you are you interested in contributing to it?
Yeah, but I don't know if I have whole knowledge to work on the C++ side of V8 or Node. I don't know if it should just patch the built-in or so. I can try.
So basically, you get in the native code, you get the pointer to the memory. You assign that to a array buffer, and that array buffer you make visible in the JavaScript side of things.
Similar what was done in the URL with URL components, saving in your objects.
Same thing, yes, same, 99% same. I can help you with that. You can reach me from OpenJS or Node.js Slack channels. Or
I don't know if I have access, or I don't know where I can get the access, but I can try. One thing that I saw in the C++ code of get category enable was they use mutex to, like, from what I understand, they lock to identify if a flag is enabled or not. So I don't know if this could be like a point of a issue from what we are doing.
I didn't quite understand it, but
okay, I can share later the piece of code that I saw a little bit problematic.
yeah. No worries. So what I can tell you is that, like, you need to create a bindable data struct in C++. You need to make it snapshotable. You need to register and unregister whenever serialization occurs, which is like, this is boilerplate code. On top of that, every time you call a get function, I think you get or something, I don't know, you need to update the variable, and then you need to expose it. Yeah, see you, Robert. You need to expose it to the JavaScript side. So this function, the array is binding that array kind of attribute.
Okay, and in C++ side, I should patch the method, or I should change it directly in the V8 side?
So in C++, I'm not really quite sure about how to. One second, traits are already V8 built-ins. That's probably not mushroom. Uint8 pointer from blah 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 as a single element and change. Yeah. So the command from Ben Node.js is pretty much explanatory on this side. We just need to expose a pointer and then store it inside the uint8 array element, and then that's it.
Okay. If I had like questions, I ping you in the
Yes. Ping me on Slack and I'll be happy to answer. Or if I don't know it, I can just direct you to the correct person which has more knowledge on this than me.
Okay, thanks.
No worries. And this is extremely valuable because once you understand the basic concepts of snapshots and serializable elements and how to store and share data between C++ and JavaScript, it's going to impact how you perceive node internals, and much more optimizations would occur. And this is what happened to me, and I'm excited that you're interested on this.
Are all these, things about snapshots and all, I wasn't really able to find any kind of guides or documentation on it. Is there any such documentation or no?
I don't think there is any specific documentations. Joey has most of the knowledge. There are a couple of blog posts that shares about V8 snapshots. I don't know which ones, but if I found it, I can share it with you.
Okay, maybe we can update the documentation on the C++
Yes.
SRC readme only. Yes.
Yeah. Actually, let me see. No, anyways, I will. If I find it, I will share it with you, or I can share it with performance team in an issue, and then we all can leverage from it. So, are there any other questions that you would like to share, ask?
There are no questions. I think one was, finding places where we can add fast calls, right? That is something that is kind of difficult because C++ side doesn't really have function signatures like JavaScript one has. So that is one thing we can maybe, everybody can find, play hide and seek and find possible functions that have simple signatures and can, return in types that V8 supports. That is one thing that is actionable, I think.
Yeah. I mostly go file by file in order to understand it, just to find where we can use V8 fast APIs. I think that there needs to be an automated way of detecting whether those primitives are return types of certain functions. But I don't know.
Probably there
Yeah.
isn't, yeah. So that's one thing that everybody in the performance team can do.
Yeah.
Look out for.
By the way, if you're interested in, like, if you're looking for something to optimize, the Node path module, particularly specific functions like resolve, is implemented in the JavaScript side, and because of that, it's super slow. And if we move it to C++ side, it will hopefully have a much more impact.
I see. Okay. Okay, we'll look into this.
So Vinicius, I think the code that you shared has a similar approach. You have an access to the pointer and you lock it and you access to it, and then you return the pointer to it, and that's how you know if tracing category is enabled or not. Because whenever you want to update that, like any process, like any function in the V8 can do it, and that's why you need mutex to lock it and update it and so on and so forth.
Okay. So yeah, I think so. The solution by Ben was already considering this result of this function. I was worried that this function was doing something that we cannot like modify or change, but okay.
No, like the only thing that you need to do is there's this inside this tracing file. 1 second, let me look. Node tracing events. There's this get enabled categories function. And inside that you will see get tracing agent writer agent and get enabled categories, right? So whenever you have this, or you get the access to the controller and you get access to the what was Ben said. So platform get tracing controller, yes. And then you get access to get category group enabled, Node HTTP. And if you have the pointer to it, you don't need to update get enabled categories or anywhere else because it's the pointer. And that's why Ben's solution is the most efficient one, I guess.
Okay. Nice.
Yeah. So again, I'll be happy to help you. Just ping me on Slack. And I think Ulysses shared the OpenJS Foundation Slack channel, openjs.org/collaboration, and you can join there.
Yeah, and you have the calendar and so on, and many other links too. So
yeah. And I recommend also documenting whatever you learn from this approach so that new collaborators can also benefit from it.
Sure. I can share on the pull request.
Yes, perfect. So yeah, I think that's it then. So if there is no other questions, we can end today's meeting.
Nope.
Okay, so thanks again for coming and see you in 2 weeks.